or NH2. Or NH2, I'm writing here this. Or NH2. Now, anybody say how many hydrogen bondings are possible with this nitrogen? How many hydrogen bondings are possible, beta?
So one.
How you say one? What is the reason? How do you say one, beta? There are, this one is what, tertiary amine. This one is the primary amine. This one is the secondary amine. Now tell me, primary amine can form how many hydrogen bondings, beta?
So 2.
Now it can form hydrogen bonding here. It can form hydrogen bonding here, right? And in addition to this one, nitrogen also can form hydrogen bonding with hydrogen. So this one common. I'm not writing about this one. It can also form a hydrogen bonding because I told you just now, hydrogen bonding can possible with hydrogen with what? Fluorine. Hydrogen bonding can possible with one more, oxygen. Hydrogen bonding can possible with what? Nitrogen. Only these three can form hydrogen bonding because these three are the more electronegative elements. Top three electronegative elements. First most, second most, third most. So these can form hydrogen bonding. So nitrogen can form hydrogen bonding, and hydrogen with this nitrogen can also form hydrogen bonding. So totally, generally it will get 2, extra 1 compulsory. This one is also compulsory. What about this secondary, beta? Secondary can give how many hydrogen?
2.
Actually 1 with including nitrogen, 1 is equal to 2 here. Here there is no hydrogen, only with nitrogen it can form. That means within it can form hydrogen bonding with water. Within it is not possible. So what I mean to say in this case, what happened? In this case, tertiary amine, there is no hydrogen bonding is possible. Only if you take tertiary amines here. Okay, it is forming with water. This nitrogen can form with water. So that is the reason first what I am saying here, just leave it the nitrogen. Leave it the nitrogen can form hydrogen bonding with water. But it can form here primary 2, it can form here 1. Now I told you already, when you have hydrogen bonding, which one? Intermolecular hydrogen bonding. Boiling point will increases or decreases because of hydrogen bonding, beta? Because of hydrogen bonding, boiling points will increases or decreases?
Increases.
Increases because there are strong force of attractions. So because of presence of strong force of attractions, boiling point what happened here? Directly proportional to what? Hydrogen bonding. Isn't it? This is the thing we need to remember. Based upon this, what we can say, this is the order. So which is having higher boiling point, beta? Primary amine. Then secondary, then tertiary. Important thing that they should have same molar mass. They should have what? Same molar mass. I can't write what happens something, one is CS3NH2, other is something what happens CS3NH, isn't it? CH2, CS3, like that I can't write. Of course it is secondary amine, you have to consider the molar mass also. See this one, same molar mass they should have. Then only you have to consider the boiling point. Now you observe this table, let me see the table now here. Now in this table, all are having almost, you see, how many carbons, beta, here? 4 carbons, here 2 to the 4, beta. Here 2 are there, here 2 are there. 2 to the 4, isn't it? Here 2 and 2. 2 carbons are there, here 2. That means same molar mass. You observe 73, 73, 73 and 72. This is alcohol. This is alcohol, leave it this one. Okay. Now all are actually what happened? Having same molar mass. This one is primary. This one is secondary. This one is tertiary. And this one is hydrocarbon beta. This one is what actually hydrocarbon alkane it is. This one is alkane. Now among primary, secondary, tertiary amines want same molar mass. That too what same molar mass. Now you observe primary is having 350, secondary is having 329, tertiary is having 310. Right? Now alkane, can it form hydrogen bonding here? Alkane? No hydrogen bond. When you have no hydrogen bond, the boiling points are what? Very less. Even though they are having what? Same molar mass. Why this hydrocarbon is having less boiling point beta? Because of absence of what? Hydrogen bonding. Now when you observe here alcohol, can alcohol form hydrogen bonding? Can alcohol form hydrogen bonding?
Yes.
Why? Because even oxygen, I told you here, you see, observe here this one. Hydrogen bonding is possible with oxygen. Now, which is more efficient, better, oxygen or nitrogen? Oxygen is more efficient when compared with nitrogen because oxygen is having more electronegative than the nitrogen. When you compare with oxygen with fluorine, fluorine will form strong hydrogen bonding. So, when you compare here, what happened? Here, oxygen is what? More electronegative. Then what happened? Then nitrogen. Therefore, here hydrogen bonding is strong. In this case, what happened? Hydrogen bonding is what here? Strong. Now, what I mean to say in this case, among primary, secondary, tertiary amines, primary amines are having more boiling point than secondary and tertiary when they are having same molar mass. Next, in alkane, there are no hydrogen bonding, so it is having what? Very less boiling point. And when you go to finally what happened? Alcohol can also form hydrogen bonding, that too very strong because of what? More electronegativity of what? Oxygen. The more electronegativity of oxygen than compared with nitrogen, isn't it? Alcohol is having strong hydrogen bonding, therefore it is having 390 yes to boiling. So in the examination, if they give what should be the order? Alcohol, isn't it? Then what happened? Amines. Then what happened? Hydrocarbon. Even if you observe alcohol when with carboxylic acid, which is having more boiling point, alcohol and carboxylic acid. When you compare alcohols and carboxylic acids, which will have more boiling point better?
Carboxylic acid.
Carboxylic acid, isn't it? First carboxylic acid, second alcohols, third amines, fourth what happened? Carbonyl compounds, fifth what happened? Ethers, sixth what happened? Next, sixth will be what? Hydrocarbons. So this will be the order actually. Very useful for you. So practice this one. You write this order, this primary, secondary, tertiary order in your notebook when it is having what? Same molar mass, and take this example. Take this table as example. It will be useful for you in examination. They can ask in different ways, right? Next, we'll move towards some chemical reactions now. Okay, solubility also let me discuss here, but I will discuss that solubility in basic character. It will come along with basic character. So we'll discuss, no need to discuss separately. We'll along with basic character, we'll discuss. Now here basic character, if you observe, basic character means what happened, you know that one. Donation of lone pair donor, basic character, isn't it? Lone pair donor is called what? Basic character. Now if you observe, which one is base beta? Primary amine or secondary amine, tertiary amine? Which one is base? I'm writing over here. And this one I'm writing. Now, which is base beta? Primary or secondary or tertiary? Which is having basic character? Anybody?
Primary.
Why primary only? What is the basic character? I told you beta. What is the meaning of character?
Lone pair donor.
Lone pair donor.
Lone pair donor.
Now, lone pairs are present in all, right? All primary, secondary, tertiary. All are having lone pair. Therefore, all they can donate this lone pair. They can donate this lone pair. All are what? Lone pair donors only. Therefore, all are what here? Basic character. All are what? Bases only. All are bases only. Right? So you can say what happened? They're all base. Not only primary, secondary, tertiary. All type primary, secondary, tertiary amines are what? Basic in nature. Okay. Now, if you observe what happened among these two, this is aliphatic beta. This is called aliphatic. Aliphatic we can call this one. And this is called what? Aryl we can call this. Aryl, when we get what happen? When we get aromatic compound. So benzene, if we get what? Aromatic is nothing but called benzene. Right? First of all, I'll discuss about this one. Then we'll go to what? Next topic. Actually, how to explain the basic character. You observe what happened. Now, I'm writing over here RNH2. I'm writing. Again, I'm writing that equation RNH2. Okay, this is the lone pair. I've taken primary amine. Now this HX means I've taken something HBr. I've taken, right? I've taken HBr. I've taken. Now this is acid. Why? Because it can donate H plus here. Okay. And this one is the base. Why it is base? Because it can donate what? Lone pair. It can donate lone pair. Now lone pair is given to what here? H plus. Now because of this, what we got here? Rn. Now nitrogen, isn't it donated lone pair to what here? H plus here. I'm again repeating this one. Nitrogen donated lone pair of electrons to the H plus here. Now what we get beta? What we get here? Now nitrogen when donate lone pair to the hydrogen, we get like this here. Hydrogen, here also hydrogen, and here also hydrogen. It got one more hydrogen. Now nitrogen when donate lone pair, nitrogen gains the positive character, and this Br minus is a counter ion, will reside around what? Positive. Now we are going to get the salt here. This reaction indicates this is what? Base actually, because it is donated lone pair to whom actually? H plus. Similarly, you can take aniline also. Same example we can take with aniline also. In place of R, you put what? Benzene, then it becomes aryl, aromatic compound. Also they're what? Basic in nature. They take an HCl, I have taken HBr, no problem. Okay. Now here, this basic character depends upon what character? What is the character here? Which character depends upon? Basic character. Okay. Now to explain this one, what I'm taking here, one more reaction I've taken here. Because this is a salt, no? What I'm doing here, I'm taking this is the salt, no? So I will take one more reaction. To explain this one, I will take one more reaction. Now in this case, what is happening? Shall I write here what happened? RNH2. Okay, RNH2. Water, shall I write H plus and OH minus? Water I'm writing at H plus and OH minus. This water I'm writing at H plus and OH minus. Here also same thing is happening. Lone pair electrons. And donated to what here? H plus. The lone pair is given to H plus. What we are going to get again? RNH3 positive character. You are going to get. Plus what happened? OH minus. So this is the products we are getting. Now rate constant. K is equal to what we can write better? K is equal to concentration of products by concentration of reactant. It is actually concentration of products by concentration of reactant. Now, what are the products here? RNH3 plus. You see here, RNH3 plus I have taken here, and OH minus you have taken here. Correct. Reactants, what we have taken? RNH2. Yes, RNH2. And what we have taken? H plus and OH minus is equal to what? Water. Generally, water does not have any concentration. No, pure water does not have any concentration. So you can leave it that one. Otherwise, you can write also that one. No problem. Now this K, if you even send what happened, if you don't send also nothing happens because water does not have any concentration. So this is base no. I'm saying this one is base no, and write down K as a KB here. B for what here? Rate constant for the base. KB means what? Rate constant for the base. K means it is rate constant for any substance. KB means what happened? Rate constant for the base here. Now finally you got something like this. This KB is equal to you got like. Now rate constant KB is directly proportional to whom beta? OH minus concentration. So higher OH minus concentration, higher the basic character. So KB directly proportional to what happened? OH minus concentration. Right? And one more thing. KB and PKB. PKB is equal to what is the formula beta? PKB is equal to formula minus log KB. Correct or not? This formula. Now KB and PKB. What is the relation between KB and PKB? Anybody? What is the relation between KB and PKB? What should be the relation here? PKB and KB?
1 by K.
Inversely proportional. That means what happened? Higher the basic character, lower the PKB. Okay. Now what I'm writing here? Basic character inversely proportional to pKb. Just like what happened, acidic character, inversely proportional to pKa. Similarly, basic character inversely proportional to what? pKb. So what I'm writing lower, for example, pKb is what? 1. That means it is having more basic character. pKb is something what happens 6, 7 like that. Then it is having less basic character. Isn't it? This is very, because in the examination they are giving pKb values better. They are giving pKb values. They don't give Ka values or Kb values. They will give pKa or pKb values. To confuse us what happened, they will give pKb values. So remember this thing actually. Remember this one. Very important better. Basic character is inversely proportional to what? pKb values. Right? Now when you observe what happened, so these are the some data. Now we'll discuss this one. We'll discuss this, how these pKb values are increasing and decreasing. Let me discuss this one now in this case. Now first of all, what I'm citing here, whenever a base attached to what? Plus side groups, donating groups, then basic character will increase. So I'm writing over here, what is the thing I'm writing? Basic character, isn't it? Directly proportional to electron donating groups. When you have electron, what is the meaning of basic character? Donation of electron. Now further, if you have more electron donating groups over that one, it can donate more number of electrons. So for example, you are donating some rupees to some person. So when you have electron donating, that means when you have some money is there, somebody is giving money to you, then you can donate more number of money to other persons. Similarly, what happened? I'm writing over here. Electron donating groups here. I'm writing over here. Shall I write here what happened? This we'll discuss later. First of all, we'll move toward this one. Right. Here I'm writing. Now here, I'm writing the primary amine beta, CH3, CH2, CH2, NH2. This is the primary amine. Secondary amine I'm writing CH3, NH, CH2, CH3. This is a secondary amine. Tertiary amine, if you observe what happened, CH3, CH3, and CH3. This one is what here? Tertiary amine. Now, when you observe here on primary amine, how many generally what happened? Remember better R. This one is R, no? R is electron donating group. R means what happened? Methyl, ethyl, propyl groups are plus side groups. If you have any doubts regarding this plus side, you search that notes, 11th class notes. You will get what are the examples of plus side. Plus side means alkyl groups here. Alkyl means what happened? You can take what happened? Methyl or ethyl groups or propyl groups. This comes under what actually? Plus side group. They donate electrons actually. Understood? Now here, say, tell me, primary amine is having how many plus side groups, beta? Primary amine is having how many plus side groups?
One.
Only one plus side groups here. Only one plus side group.
One.
Right? So I'm writing here only one plus side groups are is equal to 1. Now here how many plus side groups are there in secondary amine? How many plus side groups are there, beta? In this case? In this case, secondary amine. Methyl plus side group. I written here, no. Is it visible for you? Methyl is a plus side group and ethyl is also plus side group. Now tell me how many plus side groups are there here?
2.
2 plus side groups are there. Now methyl. How many plus side groups are there here? 3 plus groups. So I have written one order, you see. Basic character is directly proportional to number of electron donating groups here or number of plus side groups here. So you write down in your notebook, all of you better. Basic character directly proportional to number of electron donating groups here or number of plus side groups here. Number of what happened? Plus side groups are plus M groups. Okay. M means already you know mesomeric effect groups. So if you have any doubts regarding plus side, you can search 11th class, you will get everything. So what I mean to say in this case, when you observe the basic character, primary amines are what more basic, then what happens? Secondary and tertiary amines. Understood? Everyone understood here? Right? Now this is only for what gaseous phases beta. This is only for gaseous phase. Only for what gaseous phase? Only for the gaseous phase. Not for all the phases. In the if they express in terms of gas only, how to give this answer. Now you observe here, this one. This trend is followed in gaseous phase only. What I told you here, it is followed in gaseous phase only. The order of basic character of amines, you see. The order of what? Basic nature of amines in the gaseous phase follows this one. Tertiary amines are more basic than secondary amine. Secondary amines are more basic than the primary amine, and primary amines are more basic than simple ammonia. Now, when you take in aqueous state here, this one, when you take in aqueous state, you cannot follow this order. That what is the meaning of aqueous statement? These bases we are taking in the water. When you take these bases in water, you cannot follow this order actually. Okay, all of you remember this very important. What is the order of basic nature of amines in the gaseous nature? Gaseous nature. What is the more basic? Tertiary amines are more basic than secondary. Secondary amines are more basic than the primary. Very important. Next, in aqueous state, what happens? So in aqueous state, there will be some type of what exceptions are given here. I'm writing over here what? Gaseous phase. Shall I take what happened? Better to take a slide. Slide I will take. Which one is better, beta? आपको टेक्स्ट बुक में पढ़ाना और स्लाइड में पढ़ाना है? Which is what good for you? I mean, good not. I'm not asking good. Which is what happened? Is easy for you?
Slide, sir.
Slide only. But what is happens? No. Generally, what happens? You keep your
Slide.
textbook with you, and you see this one also. The second time when you read textbook, no, it will be easy for you. If I explain everything on slide, what happened when you read textbook, it will be difficult, especially average students. So they think that the textbook is different and slides are different. If I explain the textbook, what happened line to line, they thought what happened, everything is correct, and they can then when they read also when they read second time, what no, they think that what happened, same things are explained, everything what happened, okay. That is for average students, but that is the reason I'm explaining textbook. This one we discussed actually. In gaseous state, what happened? You observed tertiary, secondary, primary, and ammonia. Now let me take what happened this one. Because of aqueous state, what happens? I'm explaining on this slide this one. Right. It's finished. Now in aqueous state, what is happening? Solvation effect. Solvation effect. This is what solvation effect. Now, what is this solvation effect? Let me see this one. Now, in aqueous state, what is happening in this case? Due to steric hindrance, two reasons we have to consider. One is steric hindrance, other is solvation effect. And also what happened? Inductive effect already we studied. Plus side groups. More number of plus side groups, what happened? More basic character. Already we studied this. When you have more plus side groups, what happened? You will have more basic character. It's already studied. Now, what about steric hindrance here? Now, when you observe here, when you consider the steric hindrance, what happens? When you consider the steric hindrance. Now, which is having more steric hindrance, beta? Primary, secondary, and tertiary?
Tertiary.
Tertiary will have. I'm writing this. N, R. Now, donating the lone pair. Now, R, N, H, R, N, H2. Now, when it is donating the lone pair here, everything is free here. There is no steric hindrance. It can easily donate the lone pair. But when it is donating the lone pair, what happens? Something is there to steric hindrance. Both sides, what happens? Steric hindrance present here. When it is donating, what happens? Steric hindrance is what? Very large. So in this case, what happens? Steric indents is what? More in tertiary, isn't it? When you observe steric indents, tertiary is having more steric indents than what? Secondary. Secondary is having more steric indents than the primary. So when you consider the steric indents, basic character will be like this. So this will be the basic character. Because, sorry, not basic character. The steric indents, if we consider basic character, will be what? Primary amines are more basic than the secondary. Secondary is what? More basic than the tertiary. Why? Because this is not having steric indents, low steric indents, low steric indents it is having. So it can donate easily electron. Even though less plus side groups are there, it can donate more number of lone pairs. That means if you observe the steric indents, tertiary amines are having more steric indents. That is the reason primary amines are what? More basic. This will be the basic character. If you take what? Steric indents as a concept, and this will be the basic character. Understood beta here? If you consider the steric indents, which will be the more basic beta? Primary is the more basic. Compare with secondary and tertiary. Understood this one?
Yes, sir.
Next, we'll take the solvation effect. If you consider the solvation effect, what happened? When RNH2, solvation means adding water here. When you add water here, for RNH2, when you add water here, now what happens here? Let me see. RNH2, primary amine, when you add some water here. Now it can form hydrogen bonding with water. Here also it can form hydrogen bonding with water. And nitrogen obviously will form hydrogen bonding with water like this. Also, it can also form hydrogen bonding. This is common thing actually. Now you got something what 3 hydrogen bondings. Now if I take what secondary amine here, RH. Okay. Now here what? OH2. Now here it is common only. Everyone will get like this. So how many we got here? 2 hydrogen bondings. Next, if what happened? Tertiary amine. Tertiary amine could not form hydrogen bonding, but it can form only with nitrogen. That is what? Like this. Isn't it? Now it can form only one hydrogen. Now as number of hydrogen bondings are increasing, when hydrogen bondings are increasing, solubility also increases. Solvation will be increases here. So in which case more solvation will be there here. In this case, what happened? More solvation, more solubility, more solvation, more solubility. It will be stable in water. Now this is unstable in water because it got only one hydrogen bonding, that too with nitrogen. So it is not forming any hydrogen bonding with water, means what happened? Less stable it is. Now this will be less solvation, less stable it is. When it is less stable in water, how it can donate lone pair of electrons? The donation capacity will decrease here. So when you observe solvation effect here, when you observe this solvation effect here, this one, when you observe the solvation effect here, now which should be more basic character beta? Which should be more basic character here? Which is more soluble here? Primary is what? More than secondary than tertiary. When you consider the steric indents, this one, when you consider the steric indents, primary is more basic than secondary, secondary is more basic than tertiary. When you consider the solvent effect, primary also more basic than secondary, secondary is more basic than the tertiary. Now when you consider finally inductive effect, now which one is more basic beta? When you consider the inductive effect, which one is more basic? Only inductive effect. Anybody? Inductive effect means plus I groups, donating groups if you consider. Tell me which one is more basic?
Tertiary.
Tertiary amines are more basic than secondary and primary. So 3 things we are getting. When you take steric indents, when you take solvent effect, when you take what happened? Inductive effect. Okay. Now in all cases, see here primary is first, here primary is last. In all cases, secondary is middle. We are not changing the position of the secondary. In any case, cumulatively, if you take what happened? Cumulatively, steric indents, solvent effect, and inductive effect. Secondary basics position is not changing. Only what changing here? Primary, tertiary positions are changing. That means what happened? In aqueous state, secondary amines position will not change. Only we have to change what happened? Primary, tertiary. Now, remember here what happened. If I take like this, CH3, N, H2, then what happened? Like right. Now this one is primary, this one is what tertiary, and this one will be what here? Second. Now in this case what happened? All these cases secondary is having common position. Therefore, in active state, secondary is what? More basic. Then what happened? Tertiary, then primary. Now when you take methyl groups, this will be the order like this. When you take methyl groups, you have to follow this order. In which what happened? Tertiary is what? Not sorry. Just a minute. Right. Oh, just a minute, better. This is not correct. Just CH3, NH2, and what happened? CH3, N, CH3. Then what happens? CH3. Right. This one is the primary. This one will be the tertiary. Now, when you take methyl groups here, primary is more basic than the tertiary. Secondary always for first only, cumulatively because of these three reasons here. Now, primary is greater than tertiary. Okay, when you have methyl groups as a substituent, that means as a group, alkyl groups. But when you have ethyl groups here, when you have what ethyl groups like CH3, CH2, NH, CH2, CS. This is now ethyl group. It is ethyl group. Here also secondary is what? More basic. Now here ethyl groups when you get here. Okay, and finally what happened? This is the primary. This one will be the tertiary. This one will be the second. This will be the order. Secondary is more basic than tertiary. Tertiary is more basic than the primary. This will be the order. So when substances are what? Alkyl groups are methyl, primary is more basic than the tertiary. When this alkyl group is what? Ethyl groups here, like this, ethyl groups here. Then what happened? Tertiary is more basic than the primary. That means what is happening here? When ethyl groups are there, I am considering the placer groups here. Placer groups here. So more placer groups here, more basic. When methyl groups are there, I am considering the steric indents. When methyl group is there, I am taking the steric indents. Based on that, primary is more basic than the tertiary. But when I take what methyl groups, I am considering the domination factor is what? Inductive effect. Placer groups here. So placer groups are more, tertiary is more basic than what? Primary. But always secondary will be more basic because of what? Cumulative effect. Understood here what happened, beta? Let me see now textbook now. You observe this one. Now when you consider the hydrogen bonding here. So primary got hydrogen bondings here. 1, 2, 3. Secondary also got hydrogen bonding here. 1. Third also got 1. Okay. Now decreasing order of hydrogen bonding we are getting here. Okay. Now you see our order here actually. You see this is the ethyl group here. Correct or not? C2H5 is what type of group, beta? Ethyl group here. When you consider ethyl groups here, always secondary. This is secondary, and this part also what happened? Secondary. Okay. When you consider ethyl group, tertiary is what? More basic than the primary. Okay. Tertiary is more basic than the. But when you take methyl groups, beta, when you take methyl groups here, secondary is always first only. Primary is what? More basic than the tertiary. I am writing here primary is what? More basic than the tertiary. So what is the reason behind this one? When you take ethyl groups, which is dominating, beta? electron donating nature is dominating. When you take methyl groups here, which character is dominating beta? Steric hindrance is dominating, or soluble, that solubility is dominating. Solvation effect is dominating. So here it is discussed here. Secondly, when the alkyl group is smaller like methyl group here, there is no steric hindrance, isn't it? Therefore, it is dominating over what tertiary alkyl here. But when you take what happened, bigger alkyl group, C2H5, resulting the basic strength in terms of what happened, inductive. In terms of what happened, inductive. So cumulatively, you have to consider inductive effect, steric hindrance, and as well as what happened. What is the second one? That hydrogen bonding. Isn't solubility? Solubility we can take. Everything we can. Understood here? Any doubts? This order is very, very important, but all of you know this today homework is what is the homework for you today? In gas phase, in aqueous phase, write down the basic character here. Write down the basic character. This is the homework for you. It takes only hardly 2 or 3 minutes. Write down 3-4 times in your notebook this one. When you write 3-4 times what happened, it will be easy for you. Understood here better? Reason also you have to explain. Next, we will see what aryl amines versus ammonia. Aryl versus ammonia or alkyl amines. Now, I am writing one more thing here. CH3 and what happened? CH2, NH2. One more I am writing. Aniline. This is what here? Aniline, right? Now, among these two, ethanamine and aniline, which is more basic beta? Anybody? Is possible for you? Ethanamine. This one is aniline. Which is more basic beta?
Ethanamine.
How you say? How can you say like that? What is the reason here? Can you say? Is it correct only? What you said is correct.
Because lone pair resonance effect is seen.
Only simple reason, a resonance. See, lone pairs actually it should donate to some others. External it should donate. But what is happening here? Lone pair and pi bond are in conjugation. The lone pair and pi bond in conjugation, they are moving towards what? Ring here. It's moving towards ring here. So because of a resonance, the lone pairs are given to the benzene ring here. See here? Conjugation with benzene ring, and thus making that what is happening. Because of this, what happens you observe? Nitrogen is getting positive charge. So because of lone pair giving to what here actually? Benzene ring here. So nitrogen when it is getting positive, see? Resonance is what actually takes place all the time here. So from 1 to 5, it takes place continuously. For this type of resonance, we don't need to add any type of reagent. On its own, it will take place here. On its own, we don't add any reagent to undergo 1 to 2, 2 to 3. It takes place continuously like this here. Now, in this case, nitrogen is getting positive character. When nitrogen is getting positive character in second structure, third structure, and fourth structure, now how it can donate lone pair here? So donation of lone pair, electron donating capacity, what happened here? Decreased here. How decreased? Why it is decreased here? Because of what? Resonance. The unshared lone pair of electrons on nitrogen are given to what? Benzene ring. Okay, so that is the reason what happened. Aryl amines or aniline are less basic than what happened? Alkyl amine. This is what alkyl amines here. Why? Because this lone pair and here what happens? Single bonds are there. Now definitely what happened? It is what? More basic. So this type of questions also you may get. Whenever it, for example, if you observe like this, CH2, double bond CH, NH2. Is it more basic or less basic beta? This one. Vinylamine.
Less basic.
Less basic. Because again, lone pairs are given to what here? Because it is in conjugate. What about this one? Allyl amine? Less basic or this one? Allyl amine is less basic or more basic? More basic only. Why? Because single bond. Resonance is absent here. There is no resonance here. Resonance is absent here. Therefore, it is more basic only. Understood here? So, what I mean to say is that what? That aniline, because of resonance structures, what happened? So, that basic character will be decreased here. Understood here, madam? So, now next I am writing what here? Next, what I am writing here, you observe here what happened. I am taking example aniline only. Benzene. Benzene. All are what? Anilines only. NH2. NH2. Now, aniline generally less basic when you compare with aliphatic amines, alkyl amines, right? But when they are having what? Electron withdrawing groups. Here it is having electron donating groups. Now, basic character will increases. Because already you know electron donating groups will increases the basic character, electron withdrawing groups will decreases the basic character. You see here, OCS3, OCS3, CS3. These are what type of groups better? Donating groups, electron donating groups. Presence of these groups increases the basic character. Now NO2 group, you observe NO2 group, SO3H, COOH, and halogens. All these comes under what here? Electron withdrawing groups. You see your 11th class notebook, it will be there in this. Electron withdrawing groups will decreases because withdraw groups will withdraw electrons. In that case, what happened? The lone pairs on nitrogen density decreases. Donating groups, what they donate electrons here. When they donate electrons, what happened? On nitrogen, we will have what? More number of lone pair capacity. Density will be more. See, the lone pairs will density increases when you have electron donating groups. Understood here, everyone? Now I am writing one example over here. This is NH2 is having something. What happened? I am writing over here. Something NO2 group is right. Next I am writing what happened. Again NH2. This is nothing, not having anything actually. This is having what? Some CS3 group. Okay, CS3, right? Now this is called what? Para-toluidine. Already I told you, toluidine. Why it is told in the first class only. This para-nitroaniline. This is called what? Para-nitroaniline. Now what will be the order beta? Increasing or decreasing order for this one?
Increasing.
Increasing.
Why? Because NO2 is withdrawing group and methyl is what? Donating group. Okay, understood? This is important beta. Next, we'll take this exercise beta, this example 13.4. Arrange the following in decreasing order of their basic strength. Now you observe this is aniline beta, aromatic compound, aryl amines here. This one is what? Aliphatic, alkyl amine. So this one actually I'm writing like this: C6H5NH2. C6H5NH2. Aryl amines. Next one, C2H5NH2, primary amine. C2H5NH2, primary amine. Next, C2H5 taken 2 times. This one is what? I'm writing over here. C2H5 taken 2 times NH. This is what? Secondary amine. And lastly, what happened? NH3, it is neither anything. It is simple ammonia. Now, already I told you, aryl amines are less basic than the ammonia or primary amines. Okay, any amine and even ammonia. What here? Resonance. Because of the resonance. So if you observe what happened, you are getting lost. Now they didn't mention anything actually. They didn't mention either gas state or anything. They didn't mention here. Either gas state or aqueous state. They didn't mention. If they don't mention what happened, take as a gas phase. Because generally they are gas one. This generally naturally what happened? This ethanamine and diethylamine is are what actually gas nature only. So you take gas nature. Then secondary are more basic. You see secondary are more basic. Then what? Primary, then ammonia. In this way, we can give many number of examples. And acylation, we'll discuss tomorrow. Acylation and remaining carbolamine reaction, distinguish test. Okay, tomorrow we'll discuss remaining things actually, right? Tomorrow I will try to complete that amines. Okay, but diagenom salts are not there beta. You are having topic up to here only. You are having up to here. Now, this is the homework for you. 13.4 is the homework for you. Arrange the following in increasing order of their basic character. You see, they given here what? They didn't mention anything better. You take gas phase. If they didn't mention anything, take as a gas phase. Okay. Already we discussed this one. Okay. Everyone must complete this one. Here it is what? Aniline. It is now when you observe better, I will explain this one. I will explain this one because you see, observe here. This is C65NH2. This is C65NH2, this one. Now C6H5CH2NH2 I am writing over here. C6H5CH2NH2. Now here it is, can you call this one aliphatic amine or aromatic amine? This one. Is it aliphatic or aromatic amine? Aliphatic amine or aromatic amine? Are you there? Is it resonance is possible here?
No.
No, sir.
Lone pairs, what happened here? Free, they are free. No resonance. Now lone pairs are in resonance here. When you take a pi bond over here. So here what happened? They are not free here. Now among these two, which is more basic? This is called what? Benzyl amine beta. This is called what? Benzyl. Benzyl amine. Remember, whenever benzene is bonded with carbon like this, CH2, this part is called what? Benzyl group here. Whenever benzene is bonded like this, then it is, can be called as phenyl. If you take as a substituent, it can be called as phenyl. If it is a substituent actually. Now benzyl amine is more basic or aniline is more basic beta?
Benzyl amine.
Benzyl amine is more basic. So try to complete this one. Okay. Right? You can do this one also. Add H plus over here. Counter ion. I explained this one in the counter ion, isn't it? You can complete up to 13.5 here beta. Complete up to 13.5. Remaining I will discuss tomorrow class. Now when you observe what happened. PKB aniline is more than PKB means what happened? Reverse to what? Basic character. PKB means reverse to basic character. You can explain this one. Aniline is aromatic, having resonance here. Ethylamine is what? Not having the resonance here. No resonance here. So you can explain this one. First one. Ethylamine is soluble in water, whereas aniline is not, because of ethylamine is having what here? CH3NH2. Aniline is what here? What is the difference you are observing here? Hydrophobic nature. Bulk group is there. Hydrophobic nature. Hydrophobic nature it is. Now this is what happened. Hydrophobic also. It is also hydrophobic, but this is less here. This is what more here. Both are hydrophobic character. Because small group will have less hydrophobic character. Isn't this will discuss later. Next, orthopara directing groups in electrophilic substitution reactions. This will discuss later. This also we get next. Now this one we can do this one. 13.4. 13.4. Basic. Keep PKB values. Order. You can do this one. Aniline, para nitroaniline, para toluene. We have completed this one. Just now we completed this one. Isn't it? We have completed over here only. Here it is. Para nitroaniline, para toluene. We have completed this one. So try to complete all whatever the questions on basic character, all of you. Right? It's 13.4. is very, very important in examination point of view. 13.4 is very, very important. All are like that only, same thing. Okay. Now you have to complete today this part. 13.4 is very important. This is a homework today, assignment for you. Complete today. Tomorrow you have to post this one. I will give that link for you. Tomorrow you post this one. Tomorrow compulsory you have to post. Some students, what they are doing, they're taking the notes from other persons and they're posting the day after tomorrow. You have to do own. Then only you will get the answers. By seeing other notes, isn't it? Someone other notebooks, isn't it? That is not correct, better. Right? Please wait, I will take the attendance now. How many are absent? 3 members were absent today. Amruta. Amruta is not there.
Yes, sir, I'm there.
Anupama, Dhruv, Bhuvaneshwari, Deva, Hari Om, Manjusha, Kiran, Neha M, Neha S, Nidhi, Nikita K, Nikita T, Nishant, Parth, Patil, Adarsh. Please say present.
sir.
बैठ रहे हैं सभी लोग. That means what happened? You are just remaining one now. They are just keeping the mobile on. They are doing some other work. Devashish, Pradnya,
Yes, sir.
Pranali,
Yes, sir.
Rani.
Present, sir.
But Rani, how are you?
I'm fine, sir.
कहाँ गया 2-3 days? मैंने बोला उस दिन आपने पूरा लॉग आउट किया. समीक्षा, समरीन,
Yeah.
समरीन,
Yes, sir.
समृद्धि,
Yes, sir.
शिवानी,
Yes, sir.
श्रेया,
Yes, sir.
श्रेया,
Present, sir.
स्नेहा,
Present, sir.
then Swapnali,
Present, sir.
Tejas,
Yes, sir.
वैष्णवी बेलगांवकर,
Present, sir.
वैष्णवी के,
Present, sir.
वैष्णवी BH,
Present, sir.
PSB, absent, वैष्णवी SB, absent.
So she was present, but she got a network error.
Okay. आपको बोला उसने? आपसे बोला?
No, sir. No, sir. अभी just इसने मीटिंग किया सर इसीलिए.
वेंकटेश,
Present, sir.
विनायक. What happened to this Priyanshu? Anybody know? Nobody knows about Priyanshu. What happened to him?
Sir, out of station.
रोहिणी absent है ना? रोहिणी absent.
Present, sir.
Rohini present. Varsha also Varsha is there. Vanita. का नाम मैंने.
Present, sir.
Radhika absent. Radhika absent, I think. She's not there yet. Radhika. Radhika is absent. So I'm reading the absentee names: Radhika, Rohini, and Priyanshu. Okay, you can log out from it. You can log out now.
Thank you, sir.
Okay, better.